All right, today in lesson 106, we're going to review the effects of scaling on volume. Quite simply put, and I'm going to go ahead and put this on here. Scale factor squared equals area, and scale factor cubed, equals volume. It's not quite that simple, but that should get us by. All right, so let's get going on this.
This 3x3 cube is constructed of 27 blocks. How many blocks are needed to construct a cube with twice the dimensions of the original cube?
Thanks, Jackie. So how should we go about this? Well, like I told you on the previous slide, if we know the scale factor is 2, which we do because they said that the dimensions are twice the original cube, to figure out the new volume, we should look at the fact that 2 cubed is 8, and then just take the previous volume, or 27 blocks, and multiply that by 8, and that'll tell us how many blocks we need to construct a cube with twice the dimensions. Okay, now might seem like a difficult way to look at it, but it'll help us in some instances. Perhaps in this instance, the easier way to look at it would be if the new dimensions were twice as much, then the new dimensions would be 6. So 6 times 6 times 6 is 216. So I think that this proves that it will work. At least it worked in this one instance. Just go ahead and trust me that it will work in future instances.
An architect builds a 1/50th scale model of a proposed building for a client. The volume of the model is what fraction of the volume of the proposed building?
Well done, Victoria. Thank you. So on this one, they've basically given us the scale factor is 1/50th, and to figure out the new volume, we're going to do 1/50th cubed. 1 cubed is 1, and 50 cubed is 125,000. So the model's volume is 1/125,000th of the original building. Okay, if the dimensions are 1/50th, then the volume is 1/125,000th. Just take the scale factor and cube it.
The larger cylindrical container has the dimensions 25% greater than the smaller container. The larger container will hold about what percentage more flour than the smaller container?
Thank you, Nora. So if the dimensions are 25% greater than the original was 100, that would make the new dimensions 125% of the original, or a scale factor of 1.25. Okay, so if we're trying to figure out volume here, we'll take that scale factor, 1.25, and we'll cube it, and that comes out to 1.95, which is 195%. Okay, so it says the large container will hold about what percent more flour? More flour. So it used to be 100%, now it's 195. So we need to do a little bit of subtraction here. 195% minus 100% is 95%. And the closest answer choice up here is choice C. So we'll go with that one. It's about 100% more. So just by adding 25% to the dimensions, you can hold twice as much, 100% more, liquid in these cylinders. Okay, I don't have any more guest readers, so I guess I got to do this one myself. A crate with the given dimensions will hold 24 cubes with 12-inch sides. So this crate will hold 24 of these. How many 6-inch cubes will the crate hold? Well, I guess first of all, if we look at it, the scale factor from the small cube here to the large cube here is a scale factor of 2. So 8 of these 6-inch cubes will fit into this 12-inch cube. And I'll show you right here. If I draw this, and hopefully you can see how 8 of these 4 on the front and 4 on the back fit in here. So now all we have to do is one little piece of multiplication. So if we know that 24 of the 12-inch cubes fit into here, we'll just multiply by 8 to find out how many 6-inch cubes. So 24 times 8 is 192, so there's 192 6-inch cubes in this crate if it holds 24 12-inch cubes. That's all I've got for you today. Have a great night, and we'll see you tomorrow.